Okay, everyone, welcome to this short video where I will be talking about the Camunda Cloud CV operator version 3 that I've been working on for this last couple of months. So there is a new operator there, and this is a Kubernetes operator, and it was designed to interact with Camunda Cloud, which is a managed service offered by Camunda, where you can basically provision new process engines in there and use and connect your applications to it. So the source code for this operator can be found here in GitHub inside the Camunda Community Hub, and it's called CV Operator CC for Camunda Cloud. The main objectives of this operator is to provision and manage Camunda Cloud resources using a declarative approach. So if you are already using Kubernetes and running workloads inside your Kubernetes clusters, this should kind of like bridge the gap between Camunda Cloud and connecting your applications to the things that are provisioned inside Camunda Cloud. And also, it's designed to facilitate the creation of credentials, and this is mostly because now you are interacting with remote services instead of interacting with services that are running inside your Kubernetes clusters. So creating secrets and client IDs and all these things that you will need in order to connect to your Camunda Cloud account, the services that are running in there are facilitated by the operator. So I will be showing how to create these secrets. And it will also enable you to use like well-known Kubernetes tools with the Camunda Cloud ecosystem. The main idea there is that if you are doing GitOps or if you are using other tools to validate your YAML files, you will be able to use the same tools with Camunda Cloud resources. So in general, what we are going to be doing is we are going to install the Camunda Cloud CV operator inside Google Kubernetes engine, like inside the cluster that is running in Google. You can install this operator in any other cloud provider. It will work in the same way. And when you install it, it will automatically connect to Camunda Cloud using your credentials. So I will be showing you how to create these credentials and how to configure them. And as soon as that connection is made, then the next thing that you can do is you can deploy your services in the normal way that you're doing it, right? Like any deployments or stateful set or whatever thing that you're running inside Kubernetes. But you can also now define CV clusters, and those CV clusters are not going to be provisioned inside your Kubernetes cluster. It's going to be provisioned inside Camunda Cloud. So if we take a deeper look into this is basically representing that. So we have a Kubernetes environment where your services are running. You have all your applications running in there. We are going to install the Camunda Cloud operator, which is basically going to use the REST APIs to connect to Camunda Cloud. In Camunda Cloud, you have a web console where you can just go and create CV clusters, and you can still do that. Or you can now create new CV cluster types inside Kubernetes, and if the operator is connected, it's going to automatically provision a new CV cluster inside Camunda Cloud. If you have created already CV clusters in your Camunda Cloud account, the operator will fetch the information about those clusters and create a local resource to represent that a cluster exists. So you can make available that information to other services that might need to connect. In this case, I will be showing an application that has 3 workers. They all need to connect to a CV cluster. And in order to do that, we will create a new cluster locally in the Kubernetes environment. That will cause the operator to create a new CV cluster inside Camunda Cloud. And then we will create a secret so the worker can connect to that remote instance. So let's take a look at that. So if you don't have a Camunda Cloud account yet, you can create a new account in this link that I'm putting in here. And as soon as you have an account, you can log in, and then you will see that you will have a user interface here to create new clusters, and this will create a new process engine cluster for you and a set of components to access, for example, operate, so you can see which processes are running. We can go ahead and create one of these. Basically, this is my cluster, and this is basically how you use it. You have some parameters here, kind of like the versions and the size of the cluster that you are creating and how stable it is, right? Like again with the versions. So as soon as you create a new cluster here, basically you are provisioning this set of components, and if you are running your own services and your applications in a different environment, of course you cannot run them here. You will need to connect to this cluster. And in order to connect, what you need is you need to create a new client set of credentials here, client credentials. And in order to do that, you come here, you go into the cluster, then APIs, and then you create these new credentials, right? These credentials gives you access to different components. You need to put a name here, right? Like my credentials, right? For this cluster, right? And as soon as I create this, Basically, it shows me the client ID and the secret, and it's going to be shown once, so I need to save it somewhere else in order to be able to use it, right? So you are supposed to download this and keep it somewhere safe where you can copy then and copy for your services to connect to this cluster. So let's say that I've done that. Now the only thing that remains here is wait for the cluster to be up and running, and then I can connect and deploy my my processes in there, and then I'll start automating things. So this is super cool because the console is quite intuitive and simple. You just create clusters and then you just connect by creating new clients, and they give you the status report about the components and how much do they take in order to bootstrap. So in this case, we can see that the cluster, the CV cluster is ready, the task list component is ready, but operate is still bootstrapping, right? So we need to wait a bit in order to actually access operate. But the CV cluster, the one that is in charge of running our processes, it's ready. So this is good, but what happens when you have, let's say, 10 of these clusters, right? The last thing that you want to do is come here and manually create these clusters and operate like and manage this cluster all over time, right? Like, so you want to automate that. Luckily, you can definitely automate all these operations that I've been doing here by just clicking some buttons, and you do that by going to organization settings, cloud management APIs, and you will see here that there is a documentation for the console APIs, right? So basically you can do all the things that I've been doing manually, like by clicking buttons, by just calling some of the REST endpoints that the console is exposing. Again, for getting clusters, for creating clusters, for deleting clusters. And again, I think that this makes a lot of sense when you have multiple clusters or when you need to create clusters on demand. Let's say that you are testing your applications and in your test environment, you want to use a cluster and then just destroy it as soon as you finish running all your tests. For such situations, definitely interacting with a set of APIs where you can automate all these calls and when these clusters are created, it's super important. So that's one thing that you can do, but in order to access these APIs, you need to create another client, which basically gives you different permissions for doing different operations. In this case, creating clusters, deleting clusters, getting clusters, and also the same for the clients, for this pair of credentials that we need in order to connect. And this is really cool. And again, something that was created as part of the operator project that you can find here in GitHub is something that it's called the Go Client library, right? And this is the Go Client library for the console itself, right? So this project here, it's providing you a set of APIs written in Go that you can include in your Go applications, and also a CLI, a command line interface tool that allows you to run commands against, the Camunda Cloud account. So if you click on this video, you can see the commands that you have available, right? Like for example, listing clusters, getting all the clusters, and you can see that in action in a terminal, right? You can also download the latest release for this command line tool for Linux and for Mac, and you can start interacting with your Camunda Cloud account from the terminal. Imagine that this is really important when you are doing CI/CD, for example, and you want to create these clusters as part of a pipeline, right? Again, same examples as before. You want to create a cluster before running your tests. You can now automate that by using a binary that is going to be executed when you run your CI/CD pipelines. But this is good, but it's not deeply integrated with Kubernetes, right? Like you cannot use a command line tool from inside Kubernetes. That's why the Kubernetes operator was created, right? Like that you can find here. This is the source code for the operator. And the operator, again, it's going to be in charge of interacting with Camunda Cloud to bidirectionally sync the status of your CV clusters inside Camunda Cloud and the local cluster that you have there running. So let's take a look at how it works. Here in the README inside the repository, you can find all the instructions on how to set it up and how to run. So hopefully by looking at the demo, you can see how easy it is to just get it up and running inside your Kubernetes clusters and start interacting with your Camunda Cloud accounts like easily by just creating some Kubernetes manifests. As I mentioned before, in order to connect to your Camunda Cloud account, REST APIs for the console and to be able to automate all these creation of clusters remotely, you need to have a client credential for the cloud management APIs, right? And I've already created one and I've already stored the secret in a safe place. And you can use this with the operator that we are going to install. So basically, before installing the operator, the only thing that I need to do is I need to create a secret, a Kubernetes secret that holds these credentials. So then the operator can connect to it using those credentials. Okay. And again, the Kubernetes operator, it's just going to use the REST API behind the scenes in order to provision CV clusters. So if we go to our terminal, we are going to install the operator using Helm. You can add the Helm CV repository into your Helm installation. And then you can run just Helm install. Let's call it CC. CV is the name of the repository, and the name of the chart is CV operator CC. Right. So I'm just installing the CV operator using Helm. This is basically deploying the operator and installing a bunch of CRDs, which are basically the definitions of CV clusters and CV clients. So we can check that the operator was installed. I'm also running some other services, and this is a cluster inside Google Cloud. So we can see here that the operator is running, and the other ones are just services that needs to connect to Camunda, like a CV cluster, right? So first we are just, I've deployed all the services, so I don't need to show you that. Those are normal services that are connecting to Camunda Cloud whenever we have an account ready. So the operator is starting. We can take a look at the logs. And basically we can see here that it recognized that there is a cluster, right? Like in Camunda Cloud, the one that I've created before by using the user interface. Let me stop that you cannot see that. So, and we can do kubectl get CV clusters now. And we will be able to see that there is a new CV cluster in there that's called my cluster, right? And this has been tracked by the operator now, right? Like the operator connected to our account, and it says, okay, there is a cluster in there. Then I need to, I can, notify the user from this Kubernetes cluster here in Google Cloud that there is a new CV cluster in their account. So for example, if you have applications that can start using that cluster, that's fine. For this example, what I will do is I will provision a new cluster completely from the operator itself. So that involves just basically notifying Kubernetes that I want to create a new CV cluster, and the Kubernetes environment will just delegate that creation to the operator that I just deployed. So if we do that, we can just do that by just sending a request to the Kubernetes APIs using kubectl, and I will be sending this file to it, right? Which basically says that I want to create a new CV cluster with this name from Gates and with this specification, right? Like I want the development plan with stable releases and in Europe West, basically. So let's do that. So kubectl apply -f and CV cluster YAML file, right? So it automatically answered that, that resource was created. Now the operator will pick it up, and we can do again the same query that we ran before, like get CV clusters, right? So we can do get CV clusters, and you can see here that a new CV cluster was created with all these parameters, and now we have a new cluster ID, right? And you can also see the status here. It's unhealthy because it's just created, and it will take some time in order to boot up all the services. While we are waiting on this, we can definitely go and create a new client. So in order to create a new client, we do the same thing. But in order to create a new client, we need to specify to which cluster. So in order to do that, we have another file that is called client. And basically this creates a different type, right? Like this is a CV client. This is a CV client set of credentials. And I want to create a new set of credentials for this cluster, right? That cluster ID. And I want to call the client CC client, right? Usually we tend to create different clients for different workers or for different pieces for different software components that are going to connect. So you can keep it separated, right? So if one of these components for some reason is hacked, you can quickly go and disable that without disabling all the others, right? Imagine that you have different teams. It's good to have different set of credentials for all of them. So I can now do kubectl apply the client, right? And again, the client will be created, right? I can also monitor the client here. So I can do, for example, kubectl describe CV client, and that's the name of the client, right? And I can see some of their properties in here. And you can see that I have a new client ID, right? Like that's the client ID that gets generated. And that basically the operator went ahead and created two other Kubernetes objects, in this case, a config map and a secret. This is, again, just to store these credentials and the connection URLs to connect to these remote components in Kubernetes native objects that were designed for that. I don't want to store kind of like the secret in plain sight, and I can use other tools in Kubernetes to take care of storing these secrets in a secure place, right? And I can definitely see that I have a config map created for that. So that's my config map, and we can take a look at that. Okay, edit CM, so we can take a look at the content of the config map, and you can see here that basically are kind of like the details for connecting to this remote cluster. In this case, this is the URL for the cluster to access. This is where we need to send our credentials, and this is the client ID. And the only thing missing here is the client secret, which is stored in a secret with the same name, right? So if I do get secret, I can see that there is a CC client secret here. And basically this is the prefix that we are setting up when we created the CV client, and this is just basically saying that this is a secret. So the secret for connecting to that remote URL with that client ID, it's going to be stored in this secret. And this is really simplifying the way that we push our users to connect to our services, because the only thing that they need to do now is just make references to these config maps and secrets that were automatically created by the operator. So now they can use a templated set of environment variables that are going to fetch this information from the secrets and from the config map, and they will not need to copy and paste credentials like manually in different places, risking it to leak it somewhere else, like for example in a Git repository, right? In this way, we don't have any resource that contains credentials that can be pushed to a Git repository, and that's usually a good practice. So if, for example, I take a look at one of our pods that it's already running here, that it's a part of the deployment, and this one specifically is the one that it's basically deploying process model into Camunda Cloud, right? And because it didn't connect it yet, it hasn't deployed. But what we can do is we can edit the deploy. Deploy, that's the correct deployment. And the only thing that I need to do here, as I mentioned before, for this application to connect with Camunda Cloud is just specify a bunch of environment variables that I have in another file here. And let's take a look at those, right? So you can see here that basically I'm injecting into this container, which is the application that it's connecting, that it requires to connect with the Camunda Cloud CV cluster. And saying that, okay, for the URL of the cluster, just take a look at this config map, and that's the variable that contains the address. The same for the authorization server URL. And finally here, the secret, right? Like it's not coming from the config map, it's coming from a secret. And it's stored inside the secret as a CV client secret, basically. So again, here I'm not copying any passwords or URLs or any sensitive data. I'm just saying to this container, hey, go to the config map and to the secret to pick up all this information. So I can store it, and as soon as I save it, Kubernetes will automatically recreate that instance of the service that was running. And I can see that that's been bootstrapped. So we can take a look at the logs of that application. Right, so the application is kicking off, and you will see that at the end of the application starting, it's basically going to try to deploy a new workflow, right? So there we go. So we have an application now that it's connecting with Camunda Cloud without copying any passwords whatsoever. The operator created a config map and a secret for the cluster that we just created and that we just provisioned by submitting some YAML files to Kubernetes. And if we go here to the user interface, and if we go back to our clusters list, we can see that there is a new cluster that is healthy, and we should be able to see the same thing from here, right? Like get CV clusters. Now the report, the status should be healthy here as well, right? Like because it is healthy and there is a constant sync between the operator and the Camunda Cloud account. If I go in there, I should be able to see that there is a new client called CC client. And if I access operate now, I should be able to see that there is a new process definition here that we can start using from inside of our application. And again, all of these trying to simplify, our users that are running inside Kubernetes clusters and that they need to connect with clusters that are provisioned inside Camunda Cloud. So hopefully this all makes sense. This is quite a new project. It's community driven. You can find the source code inside GitHub, inside the Camunda community hub, CV operator CC. And if you have any issues or questions, or if you want to contribute back with the project, if you're interested in this topic, please feel free to reach out or create an issue, and we will be glad to help you to get started with the pull request or with some documentation around it. So thank you very much for listening.